Trig identities. Here are the two trig identities that we use currently. There are hundreds and hundreds of trig identities that are out there in the wild. These are just the two really important ones that we learn first. Okay, so suppose cos is a third. Find both possible values of sine. So we learnt about the unit circle in the last video. If we're looking for cos to be a third, that would mean that the x coordinate should be a third. By the way, this is 1 out to the end of the unit circle. So we're after these two values of sine. So we're after the two height values that correspond to that. Now, what you can do is you can sort of go from your cos value, get the angle back, and then get the sine value. That's sort of a longer way to do it. We could just use this trig identity here. Cos squared plus sine squared equals 1. I'm not going to prove that in this video, but it's actually not too bad to prove it, especially if you use the fact that cos is adjacent over hypotenuse and sine is opposite over hypotenuse. You might be able to prove it yourself, so that's a good exercise. But cos is a third, so we got a third squared. That's cos squared of theta. Sine squared, we don't know. Now, I should mention, with this thing here, what cos squared of theta means and sine squared of theta. Sine squared of theta means that you take all of the sine value and you square it. The reason that we don't write it as sine of theta squared is that that might look like you're squaring the angle. We want to be really clear we're squaring the whole result of doing the sine. And that's why when I've got cos squared theta, I've taken the whole cos thing and squared it. Okay. A third squared is a ninth. So you square the top and you square the bottom. You can then subtract it to get sine squared theta is 1 take a ninth. You get a whole pizza, you take one piece out of 9. You're left with 8 out of 9. That's sine squared theta. So if you want, sine is the square root of 8 over 9. You can square root the top and the bottom. Root 8 doesn't simplify much, but you do get 3 on the bottom. Now, since you did square root, you've actually got to take a plus or minus. And that actually works. So that gives you both sine values, believe it or not, because you've got the top one. So this was root 8 over 3. And this one down here was minus root 8 over 3. Now, we can get approximates for this on a calculator. So if we do root 8 over 3, it's about 0.942. And if we look at the unit circle here and I try and make the blue value, the cos about 0.3 recurring, I get about 0.94. So I know I'm on the right track. And you can get minus 0.94 down here. Groovy. All right. Cool. So next we've got this. Suppose sine is that. And they've given us an angle range. We need to find cos. So start the same way we did it before. Cos squared theta plus sine squared theta equals 1. Therefore, cos squared theta plus a quarter squared is 1. Cos squared theta plus 1 over 16 is 1. Therefore, cos squared theta is 1 take a 16th, so that's 15 sixteenths. So cos of theta is going to be plus or minus root 15 over root 16, so that's 4. All right, but they're given us an angle range. So pi over 2, if you think about it, this is 90 degrees and this is 180 degrees. So this angle would be 90 degrees there, and the blue angle here would be 180 degrees. So anything between those two angles would be this sort of region up here. Now, sine and cos, whether they're positive or negative, you can use this little acronym SATC there. It spells cast if you read it sort of from that. And what it means is that only sine is positive and the rest are negative. Only tan is positive and the rest are negative. And only cos is positive and the rest are negative. So that's one way to think about it. So the point here is, because we're in that range, cos of theta is the negative version. The other way that you can justify it is we're looking at an angle sort of out here. So some angle there. The x value will be negative and the y value will be positive because we're above the y-axis and we're below, well, we're left of the x-axis. So that's how we know cos is negative, because the x value is cos and the y value is sine. All right, continuing from the question above, find tan of theta. That's where our other identity comes in. So tan of theta is sine of theta over cos of theta. Wonderful. So sine is a quarter, and cos of theta was root 15 over 4. Now, the best way for dealing with this, well, I mean, you can use a calculator if you want. You can write it out as a quarter divided by root 15 over 4. And how you deal with fractions is you times and flip. So 4 over root 15, you flip the last bit. The 4's will cancel. So you are left with 1 over root 15. Now, I'm usually happy with that as a final answer. You can times the top and the bottom by root 15 to get the square root off the bottom, or you can chuck it into your calculator. Some people will like it written like this, root 15 over 15. So I'd mark both of those correct. I wouldn't expect you to do that second step, but if you look in like a textbook or something, the solutions will most likely be written like that bottom one.